Knowledge is indeed a true power, but to envision new possibilities, it is essential to develop the right blend of knowledge and skill in oneself. Good afternoon, everyone. I, Harshvardhan Borai, welcome you all to our distinguished guest lecture series, Vaktavya 3.0. It is an honor to have amongst us Mr. Prajesh Das, Deputy Chief Engineer Operations, LPG Department at Oil India Limited. Also, we have with us the Faculty Advisor of UPES AAPG Student Chapter, Dr. Uday Ban, from the Department of Petroleum Engineering and Earth Sciences. Corrosion is a factor that affects the oil and energy sector on a periodic basis. Some estimate the global annual cost of corrosion to the oil and gas industry as exceeding $60 billion US. In addition, corrosion commonly causes serious environmental problems such as spills and releases. This session by our esteemed guest is an essential resource which provides engineers and designers with the tools and methods to design corrosion management programs for oil and gas infrastructures, mainly focused on Cathodic Protection System. We extend a hearty welcome, sir.
Thank you. Thank you, Harsh. Should I begin?
Yes, sir. Yes, sir.
Okay. All my friends here. My name is Prajesh Das. I work here in Oil India. Harsh has already said briefly about me. Very recently, in 2 to 3 weeks back, I already gave 2 lectures on natural gas processing and process safety management to chemical engineering students and petroleum engineering students at UPES. And continuing with that same enthusiasm, when I was approached to talk about something relevant to industry, I figured that perhaps I can talk a little bit about Cathodic Protection System. Because as operational engineers working in an industry like this, especially in a downstream unit of the one I am working right now, corrosion is definitely a concern. And in today's presentation, I'll try to make you guys familiarize with one of the main anti-corrosion measure, which is Cathodic Protection System. In short, it is also known as CP system. My objective is to familiarize you with various terms and science behind and some amount of engineering involved with CP system, so that next time you get to see or get to hear about it, you will have adequate background understanding, fundamental understanding to get the knowledge about CP system. It's a vast topic. It's possible I'll try to cover. And at given point of time, if you come up with questions, just shoot. You can always stop me and ask your question. Having said that, let us begin. I'm going to turn off the video because it's taking some amount of space in my slide, in my screen. So let's go. So friends, first of all, let us understand. Of course, all of us are aware of the fundamental concept behind corrosion, right? Just to refresh, I'll just quickly go through the fundamentals once again, so that when we land up at CP system, it becomes pretty evident and clear to us that what exactly is the science and engineering behind and why we practice it that way. Now, the entire concept starts with an electrochemical cell. So, as we all know, before that, let me ask: am I audible to you all? Am I audible to you all?
Yes, sir.
Okay, because I mean, in this system, the only challenge is that since I don't get the feedback, it becomes difficult to communicate sometimes. All right. So I was talking about electrochemical cell. The entire fundamental understanding begins from a electrochemical cell. Now, there are several forms of metallic corrosion, and most occur because of the electrochemical cell formation. Okay, the fundamental components in an electrochemical corrosion cell are precisely anodic site, cathodic site, electron path, which is a metallic correction, by the way. This is the metallic correction I'm referring here, and ionic path, which is done through an electrolyte. Okay, so all four components must be present for corrosion to occur, or basically all these four components complete a electrochemical cell, and in that case corrosion will occur from anode. It is anode which will lose electron, which will lose weight, which will lose its mass. Okay, now going ahead, we'll go and learn more about it. Now coming to the main issue here, the talking about is corrosion. Now, corrosion is the process of degradation of metals, as we all know. Especially rust is something which every one of us has seen, and corrosion is a vast subject. In fact, it's a subject in engineering itself, corrosion engineering. So corrosion, as I said, it's a degradation of metals and thus losing it back to nature from where it was initially gained. So basically, uh, corrosion is the opposite process through which from ore a metal is extracted. Okay, so it's back to ore. So it's a reverse reaction. Corrosion is nothing but a reverse reaction from metal to ore again. Okay, pretty much we all are familiar. I believe all are familiar. You all are familiar with these corrosion fundamental reactions. I have taken this rust incident, rust example because it is the uh, mostly seen and mostly witnessed corrosion reaction in industries, especially focusing on oil and gas industries. So in terms of corrosion reactions, the first reaction is, of course, iron converting into Fe2 plus 2E, 2 electrons, which means when the metallic iron is losing 2 electrons, it turns into a ion, Fe2 plus ion. And this reaction occur at anode. Okay, this reaction occur at anode. At the same time, and cathode, 2 electron when react with 2 hydrogen plus ion, this of course comes from water molecule, gives H2. At the same time, this reaction takes place in cathode. At the same time, in cathode, another reaction that occur or take place is H2O plus 2 electron plus half O2, giving 2 hydrogen ion, hydroxyl ion. Okay, again Fe2 plus. Sorry, this should not be equal. This should have been. This is a mistake. This should have been plus 2 OH minus gives FeOH whole 2, ferrous hydroxide. Okay, ferrous hydroxide, when it comes in contact with water vapor, gives ferric hydroxide. Ferric hydroxide is a bit of greenish color. Finally, ferric hydroxide decomposes into ferric oxide. Fe2O3 is ferric oxide. FeO is ferrous oxide, giving, and this is basically the rust that we generally see, which is slightly brown in color. At the same time, FeO, there is ferrous oxide and ferric oxide, Fe2O3, often react with each other and makes ferrosulfuric oxide or Fe3O4. So briefly, you can see this happening in this indicative diagram, where you can see in a same metal, in a same piece of metal, an area can act as a cathodic area, another area can act as an anodic area. So you can see the first step is what? Fe oxidized at anodic area to Fe2 plus, means in anode, iron is losing its electron. Is the area from where it loses its electron. Okay. Next, in cathode, sorry, in B, next step is electrons travel it is a metallic path, okay? It is a metallic path. It travels through the metallic path to cathodic area. Cathode gains electron. Cathode gains electron. What happens on cathode again? These electrons are, this is the reaction that occur in cathodic area. The output in cathodic area is H2O and hydroxyl. Okay, this hydroxyl ion and then reduced to at cathodic area to C, because oxygen is available from A. And finally, Fe2 plus that was generated here reacts to it. This is the reaction that takes place. Fe2 plus reacts to it hydroxyl ion and creates FeOH2. At the same time, FeOH2 doesn't stop there. It is in contact with water vapor. It eventually turns into FeOH3, ferric hydroxide, sorry. At the same time, slowly a ferric hydroxide turns into rust, which is of brownish color. So this is a continuous process. So in general, referring to steel, anything that is made of steel, a lot of time, this is how, in fact, most of the time, this is how a corrosion reaction continuously take place. Okay, and then this is what you get to see as an output, as an outcome. All right, so pretty much we know what reaction goes behind, right? Now we have again, we already know about it, but just refreshing our own self. Now we have known what corrosion is, and the outcome of corrosion is devastating. We have seen rupture, we have seen metal failure, we have seen major accidents also because of material failure, which eventually is because of corrosion. Okay, so when we have identified the problem, now let us come to the solutions. Let us discuss the solutions. Corrosion control techniques. From textbook, the various corrosion control techniques that are available are environmental selection, inhibition, material selection, paints or coating, and of course finally cathodic protection. Among all these, the most used corrosion control technique in industries, especially I'm referring to oil and gas, and in fact other industries as well. And corrosion control is best achieved by providing a suitable coating supplemented by a compatible cathodic protection system or CP system. And this as a composite corrosion protection system acts best for industries like us, especially in oil and gas. The one here so what is cathodic protection? Cathodic protection is a method for preventing corrosion on submerged and underground metallic structures. Okay, it's a cathodic protection is an electrochemical process. In cathodic protection, what we do is basically an electrochemical process where DC current, direct current is applied to a metal to slow or stop corrosion currents. When properly applied, in fact, corrosion current, that is CP, stop the corrosion reaction from occurring. Cathodic protection works by placing an anode or anodes in an electrolyte to the circuit. Current flows from the anode through the electrolyte to the surface of the structure, and in that case, corrosion moves to the anode to stop further corrosion of the structure. Fundamentally, again, I just reiterate, oxidation, we all know, is loss of electron. Reduction is gain of electron. And the best way to remember this is a mnemonic called oil rig. Okay, OIL, oxidation is loss of electron. RIG is reduction is gain, that is gain of electrons. Okay, similarly, anode, where oxidation reactions take place, and cathode, where reduction reactions takes place. Means anode is the one which loses electron, and cathode is the one which gains electron. Okay, so this can again be remembered through another mnemonic called anox ratcat. Easy to remember, very easy to remember. Anox ratcat. Anode is for oxidation, ratcat reduction at the cathode. That means reduction takes place at cathode. I hope this will be helpful for you to remember this. Now let's deep dive into cathodic protection system. Let us understand it in a little better way. Now, there are two types of cathodic protection system. One we call TCP, which is temporary cathodic protection. Another one is called PCP, or permanent cathodic protection. In TCP, usually for 1 or 2 years, if cathodic protection is required, we go for TCP. I'll explain what are the fundamental interactivity, what are the differences in TCP and PCP. So in an industrial setup, if you hear about TCP, you will know that the cathodic protection is only for 1 or 2 years, and the permanent cathodic protection, it may last longer. I think let us understand cathodic protection first before I start explaining about TCP and PCP. We'll come back to this slide again. Let me explain a few more things before that. Some of the terminologies associated in CP system. I mean, this is basically for familiarization for you all. Coating and wrapping of underground pipe for CP system. It may be underground pipe, it may be underground tank, it may be tank bottom. Okay, coating and wrapping. Of coating wrapping of underground pipeline by latest technique for the holiday detection method. Now, if you happen to see this, you will know that holiday detection method is a method through which the effectivity of coating and wrapping is evaluated. Okay. Now, coating and wrapping is, you remember I talked about corrosion protection techniques. There, paint and coating was one of the technique, right? So this is what it is referring to. This coating and wrapping, whether that has been done properly or not on a metallic surface, precisely if it is storage mounted bullet vessel or it is a pipeline, then through holiday detection method, it can be determined whether the coating wrapping is properly done or not. Detection of AC-DC interference in a ROW pipeline. ROW stands for right of way pipeline. I mean, these are some of the terms that you may come across whenever you see or hear or read about CP system anywhere. Okay, going ahead. Pearson surveys, again, same thing. Pearson surveys also carried out to find defects. This is basically an above ground survey technique used to locate coating defects. Okay, I repeat, coating defects in buried pipelines, and is named after a gentleman called J.M. Pearson, who developed this technique. The survey compares the potential gradients along the pipeline measured between two movable electron ground contacts. Another one is coating conductance. How much conductance is there after the coating? After you have put the coating or wrapping over a vessel or a pipe. CPL stand for computerized potential logging. Computerized potential logging, interference and its mitigation, soil resistivity. Soil resistivity is again an important parameter when you design a CP system or cathodic protection system. Chemical analysis of various compounds around, bacterial loading evaluation for CP system. Bacterial loading, when I'm talking bacterial loading, I'm talking about basically SRB. If you guys heard about SRB stands for sulfate reacting bacteria. So these are the few things. Yes, another important stuff in CP system terminologies. TRU stand for transformer and rectifier unit. JN boxes means junction boxes. Okay. Anodes for PCP and TCP. Anodes means, as I already told you, anodes and cathodes. Anodes is the one which loses electron. Cathode is the one which gains electron. Okay. Oxidation is the reaction which takes place on anode, and reduction is the reaction which takes place on cathode. Anodes for PCP and TCP. PCP is permanent cathodic protection, and TCP is temporary cathodic protection. This is REF electrodes, means reference electrodes. Okay, reference electrodes. Polarization cell. Polarization cell is a cell which is like a chemical barrier between earthing and CP cell, CP system, cathodic protection current. I'll explain it later on. I'm just making you guys, I'm just trying to familiarize you guys with certain terminologies which we'll be going through in next few slides. Okay. Next, surge diverter. Surge diverter is another device. As you understand, surge. Okay, surge is like sudden increase. The surge diverter is a device through which, if there is any sudden lightning, okay, additional current can be diverted to ground, to earthing. So that's the kind of device, surge diverter. Test stations. Test stations are again associated with the CP system, but particularly in pipelines where natural potential cannot be taken. I mean, like, there may be areas where the pipeline is not very easily accessible. So in that case, test stations are constructed at a safe distance, at a proper distance from where is natural potential, or like PSP, pipe to soil potential. These readings can be taken. We'll know a little bit more about it in the coming slides. So this is some of the terminologies which are very much associated with Cathodic protection system. Some of the applicable standards in engineering activities, as I said in the beginning of the presentation itself, since I work in a downstream gas processing unit, the applicable standards for mounted LPG storage bullets, where Cathodic protection system is there. That means we are using Cathodic CP system. We are following these two standards. The entire basis of design for the CP system used for mounted bullet system is based on NSE ESP 0285 2011, which is for external corrosion control of underground storage tank systems by Cathodic protection, and another standard called OISD 150. OISD stands for Oil Industry Safety Directorate. OISD 150 deals with design and safety requirements for liquefied petroleum gas or LPG mounted storage facility. Now, these two standards, this is a US standard. NSE is an international organization, of course. NSE stands for National Association for Corrosion Engineers. They are the certifying body for level 1, level 2, level 3 surveyors and engineers for corrosion. And OISD is a Indian body which gives us or prepare the standards for mounted storage bullets, which mention about CP system and the standards of and the requirement of CP system or Cathodic protection system. So these are the applicable standards pertaining to our industry, my industry to be precise. Now, you all know in a conventional galvanic cell, right? If there is a battery, if a positive terminal is connected with a bulb and a negative terminal is connected like this, the current will flow from positive towards this route. It will follow this route, while the electron will flow from the opposite direction, isn't it? And this is the conventional current flow. Now, this is a conventional offshore oil rig setup using impressed current. Now, impressed current is ICCP, impressed current cathodic protection. So in that case, the oil rig which has steel pipes and steel infrastructure is provided with negative, is connected with the negative terminal of a rectifier to convert it into a cathode, okay, negatively charged, convert it into a negatively charged structure, where another part, this is aluminum anode. Of course, to complete a circuit, we need cathode, anode. We already talked about it, isn't it? To complete an electrochemical circuit, we need four elements: anode, cathode, electrolyte. In this case, this is electrolyte. Seawater is electrolyte, and metallic wire. A metallic wire. Okay, metallic wire connection. So that's how this whole circuit is completed in that case. We'll speak more about it in the coming slides. Now, I already spoke that cathodic protection. Now, break this word, cathodic protection. In the beginning, I said cathodic protection is an anti-corrosion technique. Among 5 different types of technique we have already. Out of that, cathodic protection is one of the techniques. Now, the term is cathodic protection, isn't it? Term is cathodic protection. Means, why cathodic protection? Because in a normal case, forget about everything. In a normal case, a metal will corrode. Okay, a metal will corrode when it will lose electron, right? It will lose electron when it acts as an anode. In an electrochemical cell, the anode is the one which loses electron. Okay, so in a normal case, just take an example of a normal steel pipe, which is in use. It will lose electron. Because it will act as an anode because of its electronegativity. Metals are electronegative usually. I mean, of course, in the electronegativity chart, we can always see which metal is more electronegative, which is less electronegative. We'll come to that as well. Now, before that, what we are trying to understand is we're trying to understand the cathodic protection. Now, what I'm trying to say is, if we can convert the metal into a cathode, okay, by some way or other, then the metal that I want to save from corrosion, I can save. If I can convert it into a cathode. So there are 2 ways of doing it. In industry, as an industry practice, there are 2 ways of doing it. First is called sacrificial anode cathodic protection or galvanic protection. Another one is called impressed current cathodic protection, often referred to as ICCP, impressed current cathodic protection. Are you guys with me? Because I'm not getting any feedback, so it becomes really difficult whether you guys are following me or not. Okay, thanks, man. I'm sorry. So, as I said, cathodic protection, in industry, there are 2 types. One is sacrificial anode cathodic protection. Another one is ICCP, okay, impressed current type. Now, I'll explain one by one, because this is the only 2 types of cathodic protection you're gonna see. Every time I utter the term cathodic protection, please remind yourself that cathodic protection, okay, we are talking about cathode. Remind yourself that we are talking about converting the metal into cathode. Okay, converting the metal into cathode. Why cathode? Because cathode gains electron. In an electrochemical circuit, cathode is the one which gains electron. And if we can turn the metal into a structure, into a cathode, it will not lose electron. Means it will not corrode. Means corrosion reaction can be stopped. Okay, I hope I'm making sense to you all. Okay, that's why I'm repeating these terms again and again. Cathodic protection, which means I'm trying to convert into a cathode, which means it will not lose electron, it will rather gain electron. Okay, so very fundamental idea is to stop corrosion. Corrosion will only take place when it will lose electron, when my metal will lose electron. All right, when my metal will lose electron, that is the time when it will corrode, when corrosion will take place. Please remember it. Remember. Now, going back to different types of cathodic protection. First one is, as I said, sacrificial anode cathodic. In this case, look at the circuit. Look at the circuit. In any electrochemical circuit, as I already said, one is cathode, one is anode, one has to be electrolyte, and there has to be another fourth part has to be a metallic connection. All right. The cathode is the steel, the one I want to protect. Okay, and there has to be an anode, right? Now I'll determine which metal to use as an anode. Okay, now if I can complete a circuit by putting an anode, which in an electrochemical circuit will lose electrons, then my steel will be saved. Now let me explain it in a simple terms. Say for example, where is the draw one? Okay, all right. Imagine there is a water tank. Okay, imagine there is a water tank, and you have a tape here. Okay, it's full of water. Water is over here. You have a water tank, and then there is another tank, overhead tank, right over here, over top. Okay, this is also full of water. Okay, now imagine you have opened a tape here, and water will start falling, isn't it? Water will start falling. Now at the same time, if you can open this tape at the overhead tank, the level will always remain same, isn't it? Will never come down, isn't it? You guys are following my belief. Okay, you guys are following me, right? So the very idea behind having an anode is just like this. Okay, if your cathode is supposed to lose electron, right? It's just like whatever electron it will lose for any chemical reaction or for any purpose, that amount will be refurbished from the anode. Okay, that will be refurbished from the anode side, and that is why anode is called sacrificial anode. It is the anode which is providing the electron. That is why the metal. This is the anode, which will be losing its weight over a period of time. Okay, and that is how you can save your cathode, which is basically steel structure, which is basically your tank bottom, which is basically your storage tanks, like mounted storage vessel, like pipelines, etc. Okay, so this is sacrificial anode concept. In case of impressed current cathodic protection, in case of ICCP, the fundamental is same again. However, here what you do is you force current. Okay, you force current. You put a rectifier. Okay, you put a rectifier and provide voltage drop. Potential difference. You provide potential difference, and you connect the negative terminal with the steel structure and positive terminal with the anode. Okay, so in that case, when you impress negative charge on a metal, it automatically converts cathode, right? And that's how you convert this into a cathode. And when in a circuit like this, when you have got 4 elements of a electrochemical circuit, your electrochemical reaction will always take place, and your steel will convert into a cathode. And the moment it converts into a cathode, you can see, or you can safely say that you can, to a larger extent, control your corrosion reaction. Okay, so in case of impressed current cathodic protection, you are enforcing, you are pressing current into the system. While in case of sacrificial anode cathodic protection, it is just a natural, you just provide an anode and a metallic connection. That's it. You don't provide impressed current. Okay, so from extra impressed current, you don't need to provide. All right. So these are the basic two types of cathodic protection you will get to see in industries. Now, criteria for cathodic protection. Now, this needs to be deleted, right? Yes, sir. Okay. Hope you guys are following me.
Yes, sir.
Okay. So, three primary criteria for cathodic protection are: number one, I won't say three, there are basically four. Okay, these are the four primary criteria. Uh, first one is the voltage, that is the potential difference between reference electrode. We call it, with respect to a half cell. Okay, with respect to a Cu copper sulfate, that is CaC, copper sulfate half cell. The difference of potential difference between the half cell and uh, the when the protective current is on has to be between 0.85 to about 1.15. Now I'll explain. It may sound a bit confusing. I'll explain. Now what exactly does this mean? Let me go to a picture so that I can explain it in a better way. Okay. Wait, so what it says that the primary criteria for cathodic protection for underground or submerged steel or cast iron pipes are: first one is says that minus 0.85 volt with respect to copper sulfate half cell reference electrode with protective current on. Now what does this mean? It means that this is a typical setup. This is a typical setup where you have a TR unit, which is called transformer rectifier unit. Okay, you have a vessel which is to be protected. Okay, and that is why you are providing you are providing current. So this is the current that we are providing. Okay, this is cathodic junction box. You are making it a circuit, right? And this is the positive terminal you have connected through anodic junction box. Okay, this is your anode. So you have a polymer. In this case, you have a polymeric anode. So this page says that minus 0.85 volt with respect to CuSO4 half electrode. Now, half cell, there are quite a few things. Let me explain one by one. CuSO4 is a half cell reference electrode. Again, what is meant by half cell electrode? Half cell reference electrode. Half cell means, you remember in the first slide, I showed you a complete, okay. This is a full cell. Okay, this one is a full cell, right? Now, consider this as broken like this. Okay, only this part. Consider this only this part. Oh, sorry. Consider only this part. So this part has got one electrode and electrolyte, right? One electrode and electrolyte. So this is your half cell. Now let's go to the slide. So this is the half cell I'm referring to. Okay, mind it. This is the half cell. Now okay. So CuCO4 is a in industry. So copper in the half cell, copper is the electrode and CuCO4 is the electrolyte. Okay, this is a reference electrode. Now when I'm saying reference electrode in the slide, okay, here we have a reference electrode against which you will measure the potential. Now, what potential I'm referring to? See, in impressed current cathodic protection, what we do is we provide current, right? All we do is we provide potential difference. That is in terms of voltage, okay, in terms of voltage. And that is being provided through DC current. There are quite a few things, don't confuse, okay? I'll explain slowly one by one. We provide DC current and provide potential difference, okay? And we measure the potential difference with reference cell and the reference cell and the TR unit. And that potential difference has to be in the range of 0.85. Has to be in the range of 0.85. Now there is a minus before that. Now, while explaining the next page, I'll tell you what that minus refer to. But pretty much you just try to understand that the 0.85 volt is the voltage difference, is the potential difference between a reference electrode with protective current for cathodic protection system on, which means the voltage difference between cathodic protection and this system. Now, this system comprises of, this is a complete system, okay? This system comprises of a complete electrochemical cell. This complete electrochemical cell, which is having a positive terminal and negative terminal. This negative terminal is connected with what? Cathodic junction box, which is this metal body is getting converted into a cathode, okay? And we have polymeric anode in place. We have polymeric anode in place, which is again connected with a anodic junction box or AJB. Basically, the idea is through TR unit or through a transformer rectifier unit, we are providing voltage and we are completing a circuit, an electrical circuit. Okay, by making this through this electrical circuit, what we are doing is we are making this bullet a cathode, and by making it a cathode, we are providing cathodic protection to this setup. Okay, now whether my system is working or not, how will I determine? In order to determine anything, we have to measure it. Now coming to the fact that what we will measure, then this slide will be helpful. We will be measuring the potential difference between CuCuSO4, which is we call it CSE, okay, copper sulfate half cell reference electrode. We measure the CSE half cell reference electrode potential difference between CSE half cell reference electrode and mounted bullet CP system. Potential difference between reference cell and mounted bullet system, which should be in the range of minus 0.85. This is what it means. Okay. Minus. Why minus? Minus because in a normal case, a metal, as I previously also said, in a normal case, a metal acts as a anode, which is very prone to lose electron, isn't it? Now here we are converting that anode into a cathode, okay, and minus 0.85 volt refers to the fact that against reference electrode, which is basically an anode, okay, which is basically an anode, against reference electrode, the cathode, the CP system, that is the entire mounted bullet system, is negatively charged. I think things, okay, let me keep things a little easy. Okay, here are two terms. One is called Cathodic protection system applied on and cathodic protection system not applied instead of. Now, system on and system off. Okay, mind these two terms. It says one is on and one is off. Okay, so on means when at any given point of time this setup is always providing current. Okay, always providing current, but there is a switch, especially in a ready-made setup like this. There are times when there a switch called uh, a timer switch can be provided, which means to take the reading, the electricity, the power can be turned off for a momentarily. Okay, momentarily, just to evaluate system effectiveness. All right. So it says when cathodic protection system applied on, and at one point it says that cathodic protection system not applied, that is off, which means when the cathodic protection system is on, which means the power supply is on, during that time the potential difference between this cathodic protection system and reference electrode. Okay, when the power supply is on, during that time the potential difference between the mounted bullet CP system and the reference electrode, that is the potential difference it is referring to when the system is on. And when it says instant off, which means when the power supply is off. Okay, when the power supply is off, the transformer rectifier unit is not supplying any power. Of course, it happens for 1 second or 2 seconds at the most. In that case, when the power supply is off, during that time, the potential difference between the CP system and the reference electrode. So the design criteria says that that should be around minus 0.85 volt. Okay. The third requirement is 100 millivolt of polarization voltage. 100 millivolt of polarization voltage. Now, what is the polarization voltage? Polarization voltage is the difference between natural potential and off potential. Now, what is natural potential and what is off potential? Imagine no CP, nothing. You have a voltmeter. There is a pipeline in place. Pipeline is in work. Now, if you measure the potential difference between ground and your pipe in millivolts, it will be called natural potential. It will always, I mean, if you put a voltmeter in between, I mean, it's just like in one of the slides I showed, right? Oh, sorry. Like this, like if you take a voltmeter and use one part, you connect a negative terminal to the ground and sorry, one terminal to the ground and one terminal with a pipe, and try to measure the voltage. And if the voltage is measurable in that condition, in those conditions, then you will get a reading, and that is called natural potential. Now so you now know what is natural potential, right? Next is off potential. As I said, off potential is when this is instant off. Off potential is when you turn off the power from the TR unit, and the potential difference between in that time when the power is turned off, during that time the potential difference between the CP system of mounted bullet and the reference electrode. Okay, that is your off potential. So the difference between off potential and natural potential should be 100 millivolt or more, and at the same time 300 millivolt shift from natural potential with protective current applied on, which means when the current is applied, at that time the difference between, which is on potential, you remember I talked about on potential just a while back. The on potential is when the power is on, the potential difference between the mounted bullet system and reference electrode, that potential is your on potential. So the difference between on potential and reference cell potential should be 300 millivolt or more. Okay, so these are the criteria for cathodic protection. Now, if you remember in one of the slides previously, we talked about TCP and PCP, temporary cathodic protection and permanent cathodic protection. Now, temporary cathodic protection is done in design. Okay, by now we have already learned what is cathodic protection, right? By converting my metal structure into a cathode. Now, TCP is done at the design phase when the requirement can be fulfilled for 1 or 2 years. And during that time, the measurements I just talked about, the criteria as I said, measuring the on potential, measuring the off potential, measuring the difference between natural potential and on potential, which is called shift in voltage, and difference between off potential and uh, natural potential, which is called polarization voltage. Now, these are the parameters which you need in order to design a cathodic protection setup for your structure, or the structure you want to save, which can be pipeline. In cross-country pipelines, it is always done. In oil and gas pipelines, it is pretty much always done. In vessels, in crude oil storage tanks, you carry it out, especially for tank bottoms. Underground vessels, you do. Okay, for mounted storage vessels like us, you carry it out. So you carry out TCP first, temporary cathodic protection first. You get this data, and then you finally determine how much. I mean, you get to know the design parameters, and then finally you determine for impressed current ICCP how much current you have to put, how many junction boxes you will need. Okay, how many reference electrodes you need, how many anodes you will put, and where you will put. So all these things from there on. So in TCP, so this TCP and PCP, these criteria I picked up from one of the tender from Oil India itself. Now next time onwards, if you come across TCP and PCP, you know what's right? Temporary cathodic protection and permanent cathodic protection. In temporary cathodic protection, the company seeks supply and installation of complete test lead posts, TLPs, which is nothing but testing points. As I said, in pipelines, this tender was for pipeline. Now, TLPs are the points, like as I said, there are areas where you cannot go near the pipe, which is areas which are inaccessible. So in that case, you have a test stations, which is a little bit far from the original site, but then through metallic, through cable, you can always bring the information to a distance. So test list posts or TLPs are some such locations from where you can get the potential reading from the pipes. Then supply and installation of complete KIRK, Kirk cells and surge diverters. Kirk cells are nothing but it's a cell electrochemical device which basically resembles an electrochemical safety switch. Its function is to shunt hazardous voltage to ground in installations which for reasons of corrosion protection may not be grounded via metal conductors. And surge diverters are also something like that. As I already said, surge diverters are like in case of surge in voltage, surge in current, these will divert that additional current to earthing. Okay. Supply and installation of pre-packed galvanic anode pipeline cathode connection, supply installation of complete TCP connection. TCP is temporary cathode. All I'm trying to say here is that you guys should be familiar with the terminologies associated with cathodic protection system. Supply installation MMO. MMO stands for mixed metal oxide. Okay, mixed metal oxide coated titanium anode titanium anode string. So here we are talking about an anode string in calcined coke backfill. AJB stand for anodic junction box. CPTR stand for Cathodic Protection Transformer Rectifier Unit, the unit which will provide the potential, the setup for the CP system. CSC reference cell. Along with permanent CSC reference cell. CSC is, as I said, copper sulfate reference electrodes. Okay, so yeah. So I told you that I'll go back to that slide again and explain it. So this is where we were, okay, right? Now coming back to, as I said, in today's presentation, we'll focus a little more on mounted bullet structures. If you understand this, then you can refer to CP system in pipelines and underground vessels, in tank bottoms, everywhere. So these are pretty much similar. Okay. So typically in a mounted bullet structure, sand mound, so it is kind of an underground. Okay, although it's filled with sand all around. Reference electrodes, as I showed in other diagram, reference electrodes are placed in a near vicinity of the vessel to be protected. Now, since this vessel is to be protected, the vessel will be first wrapped and coated. Okay, wrapping and coating will be done first, and then we are talking about, and then we'll go for this CP system or cathodic protection system, which means we'll turn this vessel into a cathode. And the entire arrangement is how we will convert into a cathode. Now, this structure shows that a polymeric anode is being provided. Okay, a polymeric anode is being provided, and it is connected. It is finally connected with a TR unit, which is transformer rectifier unit. Now, understand that we have a TR unit, transformer rectifier unit, which will be providing ICCP or impressed current. Okay, so we got current. There is a metallic connection. We have an anode. We have a cathode. So our circuit is complete, right? Our circuit is now complete, which means now the circuit is complete, and thus we have made this bullet a cathode. And when this metallic structure is made a cathode, is made a cathode, it will not lose electron, and this is how we'll be protecting it from corrosion. Okay, I hope you are getting things. In any case, any question, just shoot at any given point. Okay. Just to familiarize with a normal setup, this page I am coming back again and again. So in a normal setup and a normal CP system, normal CP setup, this is how things will look like. Okay, there will be a vessel. The vessel is having a vessel is the cathode, so it needs to be electrically charged negative from the negative terminal. It has to be electrically charged from the negative terminal, right? The positive terminal will be again be charged through anodic junction box and through anode, through polymeric anode. Now this is just a reference polymer. There are other anodes also. Different types of anodes are there, of course. Magnesium anode, zinc anode, things like that. And anodes which are made of different alloys also. Okay. The fundamental idea is same. You need an anode, you need a cathode. I mean, you need an anode which will lose electron. Okay, and through impulsed current, you will be making the metal or the structure to be saved a cathode. Okay, and then there is reference cell, which is again an anode, which is again connected with the REJB, means reference electrode junction box. Okay, in this structure there is inline splice. Splice is nothing but a connector connecting cables, Then isolating joints. This is very important. These joints are also known as IJ, and in industry like ours, we have got MIJ. It's called monolithic isolation joint. Monolithic isolation joint. Okay. What is this? What does this mean? This isolation joint ensures that metallic connectivity is discontinued. I mean, this vessel is not virgin, right? I mean, a lot of pipelines have to be connected with this one. It has to be. Okay. Now, in between, these kind of joints has to be connected so that the current that you are providing in this vessel should not leak. I mean, had that been a continuous metallic continuation of metallic structure, then the current would have there would have been huge current loss. So in that case, the circuit will never be complete, or in fact, it will be electrically charged. Your entire setup will be electrically charged otherwise, isn't it? So therefore, you need to break that charge. So therefore, you need to provide this kind of isolating joint. At the same time, you have to also provide polarization cell. A polarization cell is one which also acts as a surge diverter, which means from earthing. Okay, in case of any, so that normal current from the vessel should not come and reach the earthing. The polarization is kind of a chemical barrier, so that the current that you are providing in this vessel to make it a cathode should not get drained out. Okay, should not get drained out to earth, and that is why this has been provided. Polarization cell has been provided. Polarization cell, as it means, polarize. It just polarize your Catholic setup. Okay, it just polarizes your Catholic setup to get drained out. So yeah, next is in a mounted bullet setup. This is also how it looks. A number of bullets are there which are placed next to each other, completely covered in sand. There will be reference electrodes at various points, because in order to control something, we have to be able to measure it. So the idea behind putting reference electrode is that we need to measure. Okay, and then only we can determine the health, whether it is getting deteriorated or not, or it is maintaining a particular standard or not. That is why we need a reference. Okay, so the reference electrodes are for that reading. Take that reading. This diagram is showing polymeric anode. It can be metallic anode also. Okay, this is how it is placed. I mean, just in terms of location, if you think of a side view, these things are provided in this manner. Finally, corrosion monitoring. When I'm talking about corrosion monitoring, what do we do in corrosion monitoring? So Cathodic protection of assets ensure prevention of loss of metal to earth due to soil site corrosion. When it is connected with soil, the corrosion reactions, the one I have shown in the previous slides, those are the reactions we can very well restrict to a larger extent, if not entirely stop. More importantly, I am continuously emphasizing on one term, that is cathode. If you can convert it into a cathode, the entire very fundamental idea is to converting it into a cathode. In that case, the electron that the metal may lose or will lose through corrosion reactions or things like that, that will be refilled. Those electrons will be refilled from the anode. Okay, will be refilled from the anode, and that is why the attempt is to convert into a cathode the structure or the metal or the vessel or the pipeline that we want to say. Now, this is a dynamic process and requires close monitoring of CP parameters. It's not that we measure it once or we connect it once. We need to keep on measuring it to keep the system effective and efficient. Okay. See, if safety system fails or is not performing as per design, corrosion protection is ineffective. So that is why it needs to be measured and it needs to be kept effective all along. And the best part of an effective CP system is that it can protect a structure to as long as 50 years or so. In Oil India itself, we have got 1,156 kilometer pipeline for crude oil from Assam, Duliajan until Barwani in Bihar. That pipeline was commissioned in 1961. 1961. This was CP protected, and you can imagine in 2015 onwards, we have started to replace parts of that. Now we have taken up the full project to replace the entire pipeline. But until 2015, there was almost very, of course, time and again, there was some amount of maintenance here and there, but the same pipeline was working for more than 50 years or so. So you can imagine the effectiveness of CP system if properly monitored and effectively utilized. So this last line is, of course, the efficacy of CP depends on continuous monitoring to ensure desired level of parameters. Pipe to soil potential is monitored. In one of the slides, previous slides, if you remember, I said about natural potential. So this is what PSP is referring to. PSP is pipe to soil potential. That is PSP, and that is nothing but natural potential. Natural potential you can just measure against your metal to be safeguarded against earth or against soil. Okay. Now PSP versus CSC to be in the range of 0.85 minimum to 1.5 volt maximum when anaerobic bacteria are absent. Now this means that PSP, which is natural potential, versus reference potential. CSC is nothing but CuCO4, that is copper sulfate reference electrode. To be this range, this potential difference should be in the range of minus 0.85 to minus 1.5 volt. If you see the range is between this, that means it's like maintaining the CP system. Okay. It says that maximum when anaerobic bacteria are absent, no SRB, and 0.95 minimum to 1.5 volt maximum when SRB are present. The meaning is that if the soil contains anaerobic bacteria, okay, anaerobic means SRB means sulfur reducing bacteria. So in that case, the pipe to soil potential and copper sulfate reference electrode potential should be in this range. You can measure it through a voltmeter. While if anaerobic bacteria are present, in that case the reference, then the voltage has to be a little bit more. Okay, in that case the voltage has to be in that more. Now what does this mean? If the bacteria are present, of course you have to provide more voltage, you have to provide more current in order to stop the corrosion. That's what it is referring to. In a typical structure, this is how you measure PSP. Okay, this is how you measure. There is a pipeline, you just connect a test cable with a test station, you put a voltmeter, there is a copper sulfate reference electrode, CSC. This is what I was referring to, CSC, and you measure the potential difference between these 2 points, reference electrode and test station. Okay, so this is the potential here I am referring to. So this is how we have to do corrosion monitoring. So pretty much this is all I wanted to share with you. All I have shared with you is something that I have practically experienced and learned while working in Oil India. I'm open to take questions now.
Good afternoon, sir.
Good afternoon.
I have a question.
Yes, Manish.
So, what is the importance of open circuit potential in the electrochemical cell?
open circuit potential.
Yes, sir.
I am not sure. In the presentation, have I mentioned about anything of that sort?
Uh, Not in presentation, sir.
Okay.
But I have read it about open potential circuit. That's why I'm asking.
Open circuit potential. I'll get back to you later. I haven't
Okay,
heard
sir.
about it or never
Okay, sir.
studied about it. I'm sorry.
Sure, sir. It's okay, sir. And Rishabh Shoni is asking about holiday detection method.
Yeah.
Can you please explain it?
Yes. Yes, holiday detection method. There is a device. Okay, it's very easy to find it in YouTube also. If in YouTube, if you search holiday detection, there is a device which is kind of a voltmeter. Okay,
Mm.
through that you can actually find out whether there is any leakage of voltage or not. So it is basically a continuity kind of a continuity test. Okay, so by doing that, it is again a non-destructive test. The other day when I was talking about PSM, some of you might be there, right? Process safety management. I was talking about mechanical integrity and non-destructive test in that regard. So holiday detection is again a non-destructive test, NDT method, through which you determine the effectivity of this coating, this wrapping coating. This wrapping coating is done using coal tar mostly. So you get to know the thickness is proper or not. At the same time, if any place the metal is exposed, metal remained exposed or not. If the metal remained exposed, in that case, that will be the area which will be more prone, or in fact, that will be area where the corrosion will takes place the first at the very first attempt. That is why holiday detection is very important. If you search in YouTube, you'll find a device. They have a number of videos to show how holiday detection takes place, how a holiday detector works, and you can see the if the wrapping coating is fine, then you will get a zero reading. Okay, and if it is not fine, then you will get value into that meter. Okay.
Yeah. Yes, sir. I have another question.
Yeah, please.
Nimish is asking this question. In corrosion monitoring, what
Yeah.
is the material composition of testing cable? Should
Test
I
cable.
repeat it, sir?
Yeah,
Yes,
yeah.
sir.
So my friend is asking, what is the test cable?
Yes, sir.
Yeah, it can be copper cable.
Okay.
It can be copper cable.
Yeah. Another question, sir. Aditya is
Yeah,
asking.
Yeah.
Can cathodic
See, the
protection be
idea
used
behind
to
putting a
protect? Yes, sir.
the idea behind a test cable is just to get the potential from this point, that is pipeline, to the line marker. Okay, if you see, or a test station, see, this may be an underground pipe, and or maybe this area of the pipe may be inaccessible. Okay, so all you want to do is to get the potential from this part of the pipe to a place from where you can check the voltage difference or the potential difference. Okay, so that's the very purpose of test cable. That's all.
Okay, sir. Can cathodic protection be
Yeah,
used to protect ironwork exposed to atmosphere?
it may be exposed, it may be underground. Like in this case, the pipeline is underground. The mounted vessel I was talking about, this vessel was underground.
Okay.
Okay,
Okay, sir.
we can in fact underground vessels are more uh, prone to corrosion, isn't it? More prone to corrosion, um, because of a number of factors. As I said, corrosion reaction takes place when when it becomes a electrochemical circuit. The very fundamental idea is when it becomes a electrochemical circuit. For electrochemical circuit, you need 4 things, right? Anode, cathode, electrolyte, and a connecting, a
Connecting.
connection. Yeah, connecting maybe a cable or some way or other. It has to be connected. So the moment it becomes an electrochemical circuit, one, your cathode will start gaining electron, and your anode will start losing electron. Now, the metal structure which is buried, okay, the moment it is buried, it will immediately, metals are usually electronegative, which means they're characteristically they are electron donator kind of. Okay, so it will act as an anode. It will make a natural electrochemical cell with respect to another metal, and it will start losing its electrons. And if it is iron, the first thing that will happen is rust formation. And in the corrosion reactions we have seen, the rust formation is nothing but Fe2O3 or ferric oxide, or formation of ferric oxide in various steps, isn't it? The first iron loses electron, and then that electron is gained by hydrogen, by cathode, to make it OH minus or hydroxyl ion, and then certain reactions takes place. Finally, FeOH3 or ferric hydroxide turns into Fe2O3 or ferric oxide. Okay.
Yes, sir. And so, can you tell us about maintenance of CPS?
Maintenance of CPS. Okay. So you're talking about basically Cathodic Protection System maintenance. Once installed, there is the one thing that we continuously do for CPS system is looking at the MIJs, monolithic joints, taking reference electrode readings. Okay. And once in a while, like maybe we did it after 5 years here, that we check the reference electrodes. So as such, we can say it is pretty much maintenance free, because we rarely do anything more than that. So once commissioned, all we monitor and check is potential difference. I explained about it, right? On off potential. We take on off potentials regularly, and we regularly monitor the condition of the MIJs or monolithic joints. Okay. So apart from that, in terms of maintenance, seriously, this CPS, we don't really do anything much. That's the best part of it. And yes, remember that ICCP is really costly affair.
Okay.
It's a costly affair. Yeah. So you always keep that in mind because you are installing something which gonna safeguard your properties, your assets. I'm talking about pipelines or vessels or things like that for another 40-50 years. So it's always a costly affair. So the designing is being done in such a way that it remains mostly maintenance free. So as a normal practice, so as in normal practice, we really don't do anything. We don't really need to do anything as such apart from monitoring.
Okay, sir. And so, is there any standard recommendation for the distance of anode bed and pipelines for the impressed current cathodic protection in the soil?
The standards I have mentioned here, I am aware of these 2 standards, that is WISD 150 and NSCB this SPO 0285, because we have here this mounted storage bullet. That's why in the beginning itself I said about it. So far I know, I have heard about it should be within the range of 2 meters, the anode, but I don't know what the standard says or the relevant standard for NSC says. I don't know that, but in practical experience I have seen it is within 2 meters. See, the challenge is if the anode is kept at a longer distance, larger distance. I mean, just conceptual point of view, I'm saying. What is the problem? The problem is, see, when I'm providing an anode, I have to make sure that the anode is there to supply adequate electron to my cathode, right? To the structure I am interested to safeguard. Now, if the distance is more, it is not going to help. It may get influenced by some other metals around. Okay, and I don't want my anode, which in that case quite possibly a sacrificial anode, to sacrifice. I don't want to sacrifice my anode for the sake of some other metals rather than the structure I want to safeguard. You understand what I'm trying to say? So the distance should not be more. So
Yes, sir.
far I know it should be between 1 to 2 meters. Yeah. But as per as per the standard is concerned, I don't exactly know. I haven't followed that. I know these two standards for my vessels. That's all.
Okay, sir. One last question.
Yeah, please.
Why should cathodic protection and a coating be used together to protect against corrosion? Can we use them separately?
Okay, very good question. Very good question. In one of the slides, I spoke about it. In fact, I said that corrosion control is best achieved by providing a suitable coating supplemented by a compatible cathodic protection system as a composite corrosion protection system. Right now, it is need to be understood that ICCP is a costly affair, isn't it? That is, in-place current cathodic protection is a costly affair. Now, if I don't provide wrapping and coating and I just go for ICCP straight away, the amount of voltage required will be high. And at the same time, I am exposing my metal surface to direct contact with soil, with moisture, and things like that, isn't it? So, to increase the effectivity or the efficiency of the CP system, to make it work for longer duration, 30 years, 40 years, 50 years. I gave an example of our own pipeline itself, which ran for more than 55 years. Because of the fact that it was wrapped and coated, and at the same time, CP system was also provided. So CP as well as wrapping coating goes hand in hand. It's a combined package, you can say. But if the question is, can we use CP system without wrapping and coating? The answer is yes, we can. But when you talk about, just not even investing 1% of the money for wrapping coating, with respect to your CP system expenses or cost, then it doesn't hurt to spend less than 1% to get it wrapped and coated. Because in that case, your CP system efficiency is getting increased and enhanced many times, isn't it?
Yes.
I hope I could explain it.
Yes, sir. Sorry, sir. One last question.
Yeah, do.
If a pipeline gets struck by lightning, will the system be damaged?
Remember that. So surge diverter and polarization cell, these are the two kind of devices. Are you guys with me? Can you guys hear me?
Yes, sir. Yes, sir.
Yeah, okay. So surge diverter are specifically kind of device through which this additional surge in voltage. What happens when lightning will strike your pipeline or your vessel? A sudden increase in potential difference, isn't it? Sudden increase in your current. So a surge diverter is a device which will take care of that. So that additional current will not damage your system, but it will go immediately to your earthing. Okay, that is why this kind of setup is always thought of during design phase itself and implemented. Okay.
Yes, sir. All right, sir.
Thank you so much, sir, for giving us your valuable time. This insightful session has helped our budding engineers establish a broader perspective of cathodic protection and the prevention of corrosion. The objectives we learned today have certainly strengthened our concepts. May I now invite our secretary, Ms. Nandini Rajput, to extend her gratitude on behalf of the chapter.
Sorry, there was a technical glitch. Thank you so much, Harsh. I feel delighted today to thank Mr. Prajesh Das on behalf of the UPES AAPG Student Chapter. Thank you, sir, for taking out time today for all of us, and the session was really intriguing. I believe all of us got a lot to learn today, and I hope we would stay connected in future for further such sessions and hopefully in-person sessions as well. Thank you so much, sir.
My pleasure, Nandini. It was great talking to you guys, and I'm happy to share my experience with you all. Thank you, everyone. Can we call it a
Thank you,
day?
sir.
Yeah.
Thank you, sir.